Okay, so today's lecture, we're going to move on from the very broad idea of risk and what that means for us and shift into the insurance side of things. Because within insurance and risk, we see a couple of very important kind of um, ideas that we're going to use in the future when we're dealing with risk, whether it has to do with insurance or not. Okay, it's still very important, but we see it kind of crop up initially in insurance. Okay, so we've defined risk. What is a definition of insurance? For one accepted definition and a very, very thorough definition we see here, and we define the Commission on Insurance Terminology of the American Risk and Insurance Association defines insurance as the pooling of fortuitous losses by transfer of such risk to insurers. These insurers then agree to indemnify the insured, so this is people who have policies, for losses, and then provide some other benefits. Okay, so basically there's a risk transfer. Okay. We're going to pay for that loss as an insurer, and we'll provide some other kind of ancillary benefits as well. So that's kind of the gist of it, but there are a few very important words that we need to define within this definition. The first two are fortuitous and indemnification. So fortuitous just means it's by happenstance. So it's random. Okay? These aren't losses. Ideally, these are not losses that people are choosing to cause. They're not choosing to wreck their automobile. We hope. We don't want that. That's arguably a moral hazard issue. So we want fortuitous losses. Indemnification just goes back to bringing the policyholder up to their original or approximate position. We usually look at this as their approximate financial position. Okay? Their approximate financial position. And what we'll see is, if you have a policy and you suffer a loss, we start throwing in things like deductibles or co-insurance. You won't ever get 100% payback. Okay? And why don't we see that? Well, the short answer is moral hazard, but we'll cover that in later chapters. Now, the four big characteristics of insurance, and this would probably be a question that you would see on maybe the optional midterm. So what are the four characteristics of insurance and what do they entail? So just a quick note there. And you'll see this on the exam in some way, shape, or form as well. Keep in mind the exams are multiple choice though, other than the optional. So the pooling of losses. We're going to go through each of these. Okay? We're going to spend most of our time, and in fact the worksheets with expected losses, we're going to deal with the pooling of losses. So what we're doing here is we're bringing in a lot, that's a technical term, a lot of, we'll say individuals if we're looking at insurance. We're pooling them, putting them together, I mean not literally, if we're pooling their losses. So instead of insuring that one person or that one automobile, we want the 10,000 like we talked about last week. So that's a pool of 10,000. And what we're going to see today is that as we increase our pool, our objective risk, and this proxy here we're going to use a standard deviation, but our risk decreases as we increase our sample size. Just like we're estimating in statistics, as we increase our sample, it becomes closer to the population. So we're decreasing deviation. And we'll spend some time talking a little more about payment of fortuitous losses, okay, these unforeseen accidental chances, what risk transfer means, and specifically pure risk transfer. That's important. And then we'll have a brief little slide on indemnification. Okay? But the bulk of today will be spent on pooling. It's an excellent practice. We can actually get some hard numbers to show what we already know theoretically. And I think that's important. Now, as a brief aside, I'm going to present this instead of work through these problems because I show you how to work through them in the slides. And then when we move to the worksheet, I'll move this up, I will write everything down, and I think that's probably a good time for you guys to kind of run through it with me. So right now, I will try to move at a pace so you can keep notes, okay? But I want to focus on the process here and also the outcome. Okay, so what are we really doing and what do the numbers tell us? And then we'll get a little more practice and I'll give you guys more time and I'll also work through the worksheet with you. Okay, so just keep that in mind. All right, so pooling. We've already had that definition here. We're going to spread a lot of losses. So ideally, what we're going to do, we're going to have one individual and then move that to 2, 3, 4, 5, so on and so forth. And we're going to get closer and closer to some expected value. So keep in mind our definition of objective risk was what's the spread between the actual and the expected. What actually happened and what did we expect? So let's say that in some world we were able to produce a loss distribution for Greg here. Let's say that he has, an older used vehicle that's valued at $5,000, and somehow we can run a simulation and get a nice perfect distribution of the losses he would suffer and the associated probabilities of those losses. Okay? That's wonderful. That's great. And in using this, even if we have to estimate, even if it's not perfect, we can still run through and do these same tests. Okay? So he has this following loss distribution. Okay? Each probability tier is tied to the loss tier, so it's a 60% chance of 0, 25% of 500, 10% of 1,000, and then 5% out of 5,000. Okay, so they're tied in those tiers. So we have each iteration here. So we have 4 outcomes, 4 associated and mated or paired probabilities. So what might be, if Greg comes to us and says, hey, I can't afford a, kind of a $5,000 hit right now. I won't be able to buy a new car at this point in time. So I'd like to get insurance just in case. And he says, well, what premium will you charge me? What might be the first avenue we want to take here? What could we do with this entire distribution first? Well, we could get the expected loss, the average weighted loss. If we know that he on average, loses about $500 a year, then our premium, we might want to start somewhere probably above 500. We want to make money. So our first step then would be to calculate a very simple weighted average or expected loss. Here. So a very simple weighted average or expected loss. Okay, so we'll keep this up here just in case. We'll use it in the worksheets. All it is, we're going to sum up each of these losses, and we'll have, in this case, we'll have 4, but 1 through 4. There's a probability associated with it, and then some actual loss value. You could superscript this with L if you wanted to. So X here is just the loss. Okay, but it's just a weighted average of X. That's all we're doing here. So when we work through that, what does it look like? We have our first probability, again, paired with that loss. So there's a 60% chance, there's a $0 loss, 25% of 500, 10% of 1,000, and 5% of 5,000. We've probably done weighted averages before. We run through this, and of course, it's a summation, as we see. And on average, he loses $475. Now, something peculiar about this, and if we've had our stats classes, this shouldn't shock us, is he ever going to actually lose $475? No. But averages tend to do, or tend to behave that way. Okay. So it might not be that it fits within the distribution. That's fine. Okay. There are only 4 outcomes. We have these discrete outcomes. So here we've just this is just a weighted average. It's his expected loss. You could say it's the expected value of the loss, right? We've done expected value too. But it's just a weighted average. Well, that's great. That's great. Does this say anything about risk? So our objective risk, we define that as the difference between actual and expected, or the other way around. That difference is what we're concerned with. Do we have that? At this point, we do not. So we need to take this a step farther and say, all right, well, he expects to lose this, but why don't we measure the spread or dispersion about that 475? We already know he's never going to lose exactly 475, so why don't we just say, hey, we have enough information now to calculate the standard deviation, okay, the standard deviation. And really we would do, we're doing variance first, and we're just going to take the square root of it. A couple of reasons for that. One, with variances, we tend to get very large numbers, and it's also squared units. We take the square root of that, and we're back to our normal units, which would be dollars here. But deviation or variance would also tell us very much the same thing. Okay. Again, we have this here. Your X bar, that is also just your expected loss. That's the 475. So if you've noticed what I've done on the board here, instead of saying the average or X bar, I just say expected loss. Now, traditionally, most students probably see these little summation formulas here, and then once they run through the practice problems, just completely forget about them. Because once you get this down, once you get the process down, you just need to do this. You don't need to memorize that, if that makes sense. So once you get through this process, I see very few students, write this on their exam when they're working through things. Okay, once you get the process down, it's pretty simple. But to be thorough and to kind of show mathematically what we're doing here, all this is just the weighted deviation, because we're still weighting each probability and each outcome, but we're weighting how far that outcome is from the average. That's what we want to know, the actual less the expected, but we're weighting it appropriately. That gives us our variance. We take the square root, boom, we have standard deviation. We work through that, and we see we've done that. We have the first probability of 60%, which is a loss of 0. How far is that from 475? And we square that difference. We do that for each paired probability and its loss. Sum up that, right? It's the summation. We take the square root, because that's variance, take the square root of that, we get standard deviation. Right. We work through that, and what we see is that Greg's deviation about this average of $475 loss is $1,089.44. Okay. Well, that tells us a little bit more. Okay, that tells us a little bit more. And we don't have any way to compare. We don't have someone else's distribution or another distribution of Greg with a different vehicle. We don't have that. But this is still that next step, that second moment of his distribution that we're curious about. Okay. So in this case, this is our measure of risk. We have, right? This is our expected. This is what actually happens 60% of the time. And then we go through each option to weight that, and we have our actual less expected. That's exactly what we want. That fits our objective risk definition. So that's nice. Now, that was just a quick practice, because what have we not done? All right, we have said, hey, this is how we're going to measure objective risk. I'll show you how to do it, and we'll work through some problems in the future. Great. We've not pooled. That's just Greg we're looking at. So we don't have 10,000 cars. We have just Greg and his used Corolla, or whatever it may be. That's all we have. We're not pooling. So now, let's take these same two quick tools that we've learned, which is just expected loss, weighted average, and then deviation. Look at two distributions that are identical, really, but two people with the same distribution, and see what happens to their deviation and expected loss when we pool or combine them. Okay? So, let's say we have John and Jessica. They have, very fortunately for us, it's almost like this is an arbitrary example, the exact same distribution. Nice. That's going to make things a lot easier for us. If they were a little different, even if they were somewhat correlated, we would still see some gains by pooling them. So even if they are not identical, even if they are not independent, As long as they are not perfectly correlated with one another, we still see advantages to pooling. The only reason we're not working through that is because it just requires more time. We ultimately come to the same conclusion. Okay? All right, so we can work through this, just them individually, and say what's their expected loss and what's their deviation as they are now without pooling. So for the expected loss, 90% of 0 plus 10% of 5,000, I believe that's about 500. Cool. The deviation, can't really do that quite as easy in my head, but it would be 90% multiplied by 0 minus 500 squared, plus 10% multiplied by 5,000 minus 500 squared. We take the square root of that sum, and we get a nice even number, as if it were planned, of $1,500. Okay. So all I've done is just, in the back end, went through these two. Again, we'll work through the worksheet. But right now, I want to kind of just get a little practice in and kind of see where we're going to go. Look at the road first, and we'll walk down it later. All right, nothing new there. Now they want to pool their loss exposure. Okay, and that's what we want to see. We want to see what happens. We know, based on our discussion last week, that we should see their objective risk, in this case, deviation decrease. But maybe you like to see that. Maybe you want to see that. You're skeptical. Skeptical. That's a word. You're skeptical, and that's good. So if they pool, what happens, and this is something you're going to have to be comfortable with doing, is that we create a new distribution. Okay? It's no longer just two outcomes. It's a combination of two separate and thankfully independent distributions. So it creates a new distribution. So we could have not John and Jessica not losing. We could have John losing, Jessica not, Jessica losing, John not, and then finally they both could lose. Those are now our four outcomes. Thankfully, since they're independent distributions, the chances of those, so the probability in this case of A given B, is just a multiple of probabilities A and B. So John doesn't lose. That's a 90% chance we're in that world. But there still has to be another kind of roll of this 10-sided die to see if Jessica's going to lose or not. And there's a 1 in 10 chance she does. I mean, there's a 90% chance she does not. So the combined probability of that is 81%. 90% of 90. So we do the exact same thing. We have these, kind of unique die here. And what's happening with the loss? Well, it's just whatever's lost within the pool. So if just one of them loses, it's that 5,000. But now what we've done is our maximum possible loss has actually doubled. And your loss is always going to go up. Your total loss is always going to go up as you add in more insureds or more individuals. Right? It's never going to go down because it's a pure risk. They're going to have a loss or not. So we've created this new distribution here. Let's do the expected loss. We go through this, and for the entire pool, the expected loss is 1,000. What is that per person? We divide it by 2, and we say, wait a minute, that's exactly the same. Well, expected loss is a linear operator. So as we increase n, we see the expected loss go up linearly. So if it's 500, we go to 2, it's 1,000, 3, it's 1,500, 4, it's 2,000, so on and so forth. So it's linear. Okay. So did they gain anything? Did they reduce their expected loss per person? They did not. They will not. It's not going to happen. Okay. But what about deviation? So if we work through the deviation problem here, we see for the entire pool, keep in mind this entire pool, the standard deviation is $2,121.32. That's for the pool. We divide that by 2, and we're at $1,060.66, which is less than 1,500, meaning they have reduced their individual deviation, meaning that they have reduced the risk. So the objective risk has decreased as the sample size has increased, which is something that we already know, but now we can see it, and that's great. Now, so as the pool increases, the expected loss per person, so per person stays the same, but the standard deviation per person decreases. So this is strictly per person, per individual. So we decrease it by $439.34. Great, great. Now, before we go through the worksheet, I do want to make a quick point about diminishing returns. So if you had your econ classes before, you're probably aware of the diminishing returns effect that we see in a lot of things. Very few things are linear. Very few returns are linear. We see this with pooling too. So the gist of it is, if I keep adding more people, like Jessica and John, to that pool, it's not going to decrease by $439 every single time. It's going to keep decreasing, but at a decreasing rate. So it's going to decrease, but at a decreasing rate. So the definition here, so as one unit of input is increased, there is some point in which the next unit of output doesn't give us back the same amount. That's basically it. So for us, it's kind of weird because we're actually wanting, our output is to lower deviation. So pooling size is our input, while reduction of deviation is what we want to do. But it's not going to reduce at the same amount. And I do work through a quick problem, and I just want you to be aware of this. This is not the worksheet. You will not have to work through this on the exam, but I just wanted to show you this example. So we have the same distribution, and let's say Summer, she wants to pool with John and Jessica. So I'll run through this for you. We have far more options. There are 8 different options now. I'll run through the same thing. We see expected loss goes up by 500 because it added one more person. It's still 500 per person. So that's exactly what we would expect. We do the deviation, divide this by 3, by n, which is 866, and it is still less. It has still reduced. So we went from 1060 to 866, but it's less of a decrease. So recall we decreased by $439. We add that third person, we only decreased by 194. And this would keep happening. And theoretically, this marginal decrease, it's always going to be greater than 0. But it's going to get closer and closer to 0. Okay? So there's an asymptote there, and it's at 0. But it will never reach it. So deviation is never going to be 0. You could say if we have the entire population, then I guess we could argue there's no deviation. Okay, if we could somehow have the entire population. Okay, highly unlikely. All right, so what I would like to do is finish up these next few slides and then move on to worksheet 1. Okay, so we will work through all these problems except for this adding a third person. We'll work through all these problems momentarily. Okay, this is again a hybrid modality, a little different, but I'm hoping that's the best way I'm thinking that's the best way to do this. Okay, all right, so we'll come back to worksheet 1. All right, so what do we see here? As we add in more individuals, the deviation decreases, expected loss does not. If we keep adding more, we're getting back less, but it's still going down like we want it to. Okay? It's still going down. What do I expect from you in the future? To be able to calculate expected loss, standard deviation, and create a pool distribution, and also calculate loss and standard deviation for that pool. Okay? And that's what we'll work through again momentarily. Okay, so questions about pooling right now? Great, great. If that changes, please raise your hand. All right, so I want to identify again these other 3 big points here, kind of in one slide. This is a bit busy, okay, but I've truncated this just again for the hybrid modality that we're going through. So fortuitous loss, it's by chance. It's by chance. And the law of large numbers, that pooling kind of requires that it's by chance. Because if there's some choice element, it could mean that there's some correlation, and if there's perfect correlation for whatever reason, then we're not going to see really any gains of pooling if there's perfect correlation. Okay. The risk transfer, boom. If you're taking notes or you've got this out, underline it's a pure risk transfer. In an ideal scenario, it's a pure risk transfer. We don't want someone, insuring something and then being able to make a claim and somehow gain monetarily from that. And then identification here, I've identified this in a stronger position, is that it's actually approximate. You're approximately brought up to your original position. So that idea of making whole is not really true. We add in deductibles, and that's not going to happen. But approximate. Now, these last couple of slides, I talked, a little bit about what it means, what an ideally insurable risk is, and how, if we don't meet some of these qualifications, then we lose out on some pooling effects, or it makes it so it's no longer, a fortuitous loss. Okay. So what we would like for a risk, so when we're pooling these people together and doing these pooling problems, what we would like is that we have a large number of somewhat similar risk. So this is not diversification. Pooling is not diversification. Diversification, we don't want similar types of risk in our portfolio. Now, what we don't want within these, we don't want them to be correlated. But we want the units, the type of loss, to be similar. So it's not really diversification. They're separate. We want it to be accidental and fortuitous. We want to be able to determine, so how much is it going to cost? Related to that, skipping a step, we want to be able to look at the probability. How frequently does this happen? So how much and how often. Related to correlation, what we mean here by catastrophic loss, and we kind of dipped our toes in this last week, what we mean by catastrophic loss, maybe not is the traditional definition. What we mean for insurance purposes and pooling purposes is that they're not highly correlated. So these units here, these exposure units, whoever we're pooling, we don't want them highly correlated. That doesn't mean that you can't find insurance for things such as that. A good example will be windstorm damage or flooding. Those tend to be catastrophic. If one house in a neighborhood floods, high likelihood that a few of those houses in that neighborhood will also flood. Okay? If one beach house gets blown away by a hurricane, then most of the other beach houses near it are probably also going to be blown away by a hurricane. So that's highly correlated and tied to that one event there. We also want an economically feasible premium. Okay? We want to charge enough to keep the market stable, but not too much so that good risks drop out. What happens if we don't have an economically feasible premium is it could lead to adverse selection. So we've discussed one of the big kind of theoretical positions in risk last week when we discussed asymmetric information and then a little bit on moral hazard. So I guess that's two big tenets. Another big point or tenet is adverse selection. Now, some ways we can explain this is just that only the people who need insurance purchase insurance. And that might seem kind of silly at first, and I'm not trying to be cavalier with it. It might seem a little silly at first. But a better way to say that is that we have those people who are high risk, and that could be the ones who need the insurance, right? There's nothing wrong with needing coverage. They want to pay standard rates. So they're high risk and they want the premium that the low risk pays. What happens if adverse selection is not mitigated? We have high risk entering the pool, getting a good premium, way too good. The losses are much higher than expected. We have to raise the prices. The bad risks stay in, the good risks drop out. That keeps compounding and compounding, and we see essentially a death spiral in which that premium is no longer economically feasible. We've lost the good risk in the pool, and now we have an uninsurable, we'll say, population. Question?
Yeah. So Okay, in the state of Florida, like, you don't have to purchase bodily injury coverage on your automobile insurance, okay? So would that be adverse selection since it's not required, but you'll still cover it, like, purchase it because of that risk?
So that's an excellent question. And what's your name?
Sorry.
Tori. So Tori asked, and I'm going to paraphrase a little bit. If there are some coverages that are not voluntary, so that you can't choose them, okay, and you have some that are, I think the question that Tori is asking, correct me if I'm wrong, is that if there's a voluntary choice, does it increase adverse selection? Is that what you're asking?
Yeah.
Absolutely. So that's an excellent question. If there's a choice to purchase this product, if I can choose to purchase it, does that increase adverse selection? Absolutely. A more interesting way to look at it is if people can't choose and it's mandatory to have insurance coverage. Let's say that everyone has to have health insurance coverage. Or most states require you to have personal auto coverage. And there are some stipulations to that. To flip that question, if we say you have to purchase it, you're not really selecting. So if you can't select, there's arguably no adverse selection. And I say arguably because I like to stray from absolutes. But if you can somehow remove selection, if you make a policy mandatory, it's hard to say that adverse selection can exist. You can't have people choosing, or if you take away their choice, it's hard to say that you're going to have adverse selection because there's no selection to begin with. And that's one of the reasons that we see things, maybe like health insurance, we say that personal auto, some auto policies, you still choose not to drive a car, I guess. Medicare, Social Security, you're paying into that. If you're working right now and you're not getting paid under the table, you're paying into Social Security right now. I am, you are, all are. So there are some places where we'll see, especially with social programs, that sometimes they have to be mandatory. And if we go back to those ideally insurable risks, some risk, like if we use Medicare as an example, which traditionally we see that as healthcare for older individuals, that's a high-risk group, okay? And there's nothing wrong with that. When I'm 65, I will be a higher risk than when I'm 30 or 35, or 20 or 25, okay? Well, maybe not 20 or 25, it depends. Depends on my risk preferences, okay? But that is an excellent question, okay? An excellent question. So if there is selection, then we would see more adverse selection. If it's mandatory, for all intents and purposes, we say there will be no adverse selection. If you can't select, there's no adverse selection. That's an excellent question. Tori, right? Thanks, Tori. Okay, so how do we control that? Simple answers here. Underwriting, all that means for this point in time, because we haven't covered that chapter, all that means is that we're making sure those high risks aren't sneaking under the radar. It's like, whoa, wait a minute, you're high risk, you can't pay that nice low premium. Okay, you're going to suffer more losses. Okay, so we can offer different policies or choices, right? So underwriting helps, and then certain policy provisions. Okay, certain policy provisions. Okay, requiring that you have an auto policy. Giving a 2-year window on suicides for life insurance, things like that. Okay, so policy provisions and underwriting. All right. Now, so questions about Chapter 2 before we work on Worksheet 1. Okay, so traditionally I like to print the worksheets out for you, but I don't know if that's the safest thing to do because I would have to touch it and all that. So what I'm going to do, I will close this, move this up, and I will write the distributions and the questions from the worksheet on the board. Okay, so this is Worksheet 1, but I'll give you the gist of it. Again, these are some growing pains due to us switching to this hybrid modality. But if you have your laptop or, if you want to look at it on your phone, these are different times, modern times, I guess. So that's fine with me. My worksheets here. So we'll be working through Worksheet 1, but the gist of it is I want us to go over the pooling questions. So I start out on Worksheet 1, And I give you guys just, hey, here's a distribution, just like we saw with Greg. There are 4 outcomes, 4 probabilities. What's the expected loss and what's the deviation? So I give that to you, and the key, I'll work through all of that for you. So what I'd like to spend class time on today is the pooling part, right? Because if you can do the pooling problems, which means combining the 2 distributions, creating a new distribution, and then doing expected loss and deviation, then the standard kind of questions are, they're just practice, right? So it's necessary you know how to do them, okay, to be able to ask the pooling questions, right? So what we're going to be working on, and I want to make sure that for your friends watching at home, they can see the entirety of the board. Yeah, good. So this is going to be worksheet number 1. We are actually going to work through, let's see, the pooling problems, which are 3, 4, 5, and 6. Okay? Okay, 3, 4, 5, and 6. Now I'll go ahead and give you the probabilities. Again, laptops or even your phone, if you want to use that to look at, that's absolutely fine. But I'll go ahead and give you the distribution that we're looking at here. So we have Trey and Mike. They have the following probability distribution. So we have our probabilities and our loss. They're both the same. Let's keep it consistent with the worksheet here. So I do losses and probabilities. So $0 loss at a probability of 75%. And then they could have a $25,000 loss. There's a 25% chance of that. So the first thing that I ask you to do is, what are they saying now? So what's the expected loss? And we'll use a superscript here for the individual. What's the expected loss for the individual? So this will be number 3. And it doesn't matter which one we pick, again, they're exactly the same. So we just have a 75% chance of a $0 loss, plus a 25% chance of that $25,000 loss. And I believe if you do that, you get $6,250. Since I've given you guys the go ahead to use your phone, I did not bring my calculator, was not prepared, but I will use my phone. So 25,000 times 0.25 is 6,250. This is 0 all day long, so this is what you get. Okay. What is the standard deviation of the losses? And again, this is for each individual. I'm just using these superscripts here. As long as you keep tabs on what you're doing, then it's all well and good. Let me know if I get too close to it. I just noticed that. Sorry. Want everyone to feel safe here. All right, so what's the deviation of their loss without pooling? Well, what's the average? It's the 6,250. We're going to take the square root of kind of this entire thing that we're working with here. There's a 75% chance we have a $0 loss. How far is that from the 25,000? We're going to square that difference. And some 25% chance of, the average is not 25,000. It's 6,250. We just worked through that. And then we want to calculate the weighted spread for the second outcome. If you work through these, 6,250. get 29,296,875. First. Then $87,890,625 when we run through the spread for this probability. I'm also just going ahead and weighting it by the probability. So I've skipped kind of one step there. So 87,890 and 625. You sum these, take the square root. So the sum of these is our variance. So once we sum these, that's the variance, if we need to know that, or if I ask you for that. So the sum of these two, that's the variance. And, technically one thing I haven't mentioned here, so we're taking, the units here are dollars, and we're squaring them. So you sum these two, you get the variance, and it's technically in dollars squared. Not very meaningful to us. Because not only is the amount squared, the units are too. Now let's see, so if you do this, you should get 10,825 and about 32 cents. So there'll be some rounding here as well. 825 and 32 cents. That is the standard deviation of the loss for each individual. So this is where they stand. This is where they stand. We want to know if pooling is going to be advantageous to them. So this is 3, this is 4. So 5, I ask you to do the expected loss for the pool. So we can just multiply the current expected loss by the number of people in the pool. We can do that. So we want to know expected loss of the pool. We could just go ahead and skip a step and say, oh, it's this multiplied by 2. Be 12.5. But since this is practice and we want to kind of work through this, we first need what? Our new pool, our new distribution. Okay, so make sure your friends at home can see this. We should have enough room right here to create the new distribution. So we have our losses and our probabilities. So the first kind of outcome that I think is good to look at was the chance that neither of them lose. Okay, so that probability is 0.75 times 0.75. The loss would be 0. What's the outcome, or what's the chance, the probability that one loses, the other doesn't? 25%, 75%. And we kind of have the flip of that. And we're agnostic to this when we're looking at the pool. We don't care who's losing. These two are exactly the same. We can just multiply it by 2. Because the loss is going to be the same as well, which would be $25,000. And then finally, that kind of no loss, we'll say, I guess, a total loss for this pool. And it's going to be, they both lose 25,000, which is a total of 50,000. Again, to get expected loss, we could just multiply the individual loss by the number of individuals. So, spoiler alert, it's 12,500. But this will definitely be beneficial for our probabilities when we look at the standard deviation, because it is not linear. We can't just multiply linearly and get our nice clean answer. Oh, so the probabilities associated with this, 0.5625, 0.1875, and then 0.0625 here. And because they're independent, we can just multiply straight across, probably with A given B, assuming independence. We have it here. And they are conditional, but. So we're going to work through the expected loss for the pool here using our numbers. So it's a 56.25% chance we have a $0 loss. There's the 18.875 that we have a $25,000 loss. We have that again. And then finally, there's the smaller chance we have the full loss. Okay. So that would be the weighted average, our expected loss or expected value of the loss. For the entire pool, work through this, you should get 12,500. Again, if you just want to quickly skip the step, this is a linear estimation. You just multiply by 2 or 3 or 4, however you use the pool. Great, so we have that. Then I say, all right, well, what benefits do they get? Do they see a reduction in their risk? In this case, do they see a reduction in their deviation? So the best way to do that is say, all right, well, what's the standard deviation of the loss now that we're kind of pooling everybody? Okay. So let's set this up here. I need a little bit of room. Take the square root of it. I could put it in brackets and raise it to the half power. I don't know what's cleaner to do. So how would we set this up? Well, let's go by probabilities here. What's the first kind of actual less expected? Okay. What's the first actual less expected? Well, we would suffer, in this case, an actual loss of 0, less our expected of 25, or excuse me, 12.5. The next two outcomes are really kind of the same for the distribution. One loses, the other doesn't. But there are two outcomes that lead us to that. So what's their spread? Well, in that case, the actual is 25,000. So that's the spread. So that's the actual less expected, right? This is an objective risk too, but we're just weighting it appropriately. That could also happen again. You could just multiply it by 2. Let's be thorough here for practice. And then finally, we have that big loss. So the actual loss there is 50,000. So a higher spread than our other options. Okay, now, so you work through this. I'm limited on board space here. How about you guys work through it? Quick practice, as I am also working through it. Do remember, the common error that I will see is maybe not keeping the pooled average. So you see here, we're using 12,500 because we're interested in the pooled numbers. We're not using 6,250. That's for the individual. So I might see common errors, people will put 6,250 there. Otherwise, I can't think of any, like I say, common elements to the errors that I will see. Okay, so if you do that, you should get for the pool $15,309, and I rounded up a little bit, it's about 31 cents. That's for the pool. Divide that by 2, the per person deviation is $7,654.66. Again, there's some rounding there, but 66 cents. We compare this to their original deviation of 10,825. Has their deviation decreased? Yes. Has their risk decreased? Yes. Because we're using deviation to measure the risk. So have they gained anything? Yes. By pooling, they have reduced their uncertainty, their objective risk, their deviation. So what I expect, from you guys in a testing situation, so keeping in mind I ask multiple choice questions. So due to rounding errors, I would not give you this answer and then one that's 5 cents above it. Okay? So the rounding, you probably, if you do it correctly and you're off by 5 cents, then you're not off. Then that's the answer. Okay? So what I expect from you, I want you to be able to create the pooled distribution like we did in class. I want you to conceptually understand what's happening to the pool or the deviation per person as we do it. And then be able to show it. So as you work through this, you should know that per person, if you do it correctly, is going to be lower than what you started out with. We've shown that. Now, do you guys have any questions about Chapter 2? Any questions about Chapter 2? So I will post the key to Problem Set or Worksheet 1. Worksheet 2 is optional. You can bring it in on exam day to earn up to 1 extra point. If you would like to see the key for it, just email me what you've done so far. I won't grade it, but I will send you the key. If enough people do that, I'll probably just post the key anyway. If you need extra practice, extra problems, email me, and I will send you the extra problem sheets that I have, along with the key to do as you see fit. Okay. Worksheet 2 is optional. You can bring it on exam day. If you want to see the key, send me what you've done so far, and I will send the key to you. And what you do with the key from there on out is fine with me. Okay. All right. So keep in mind, 1 pack-back question, 2 responses. Do that by Sunday, 11:59 p.m. Okay. Do that. You have the optional kind of practice assignments here. Otherwise, hope you guys have a good weekend. Stay safe. If you have any questions or concerns, as always, I have virtual office hours. Feel free to come and talk to me after class or email me and let me know your concerns. All right. Thanks, guys. Have a good day.
I have a question.
Yes, Tori.
Okay, for the last one that we just did. Okay.
No.